Hello there, fourth and fifth graders, and welcome to your next math lesson. Today's math lesson is called Solve Measurement Problems. If you do have this worksheet with you, then just go ahead and do the worksheet with me. But if you don't have this worksheet with me, then you don't need to write all of these word problems. Simply just do the actual work with me. But don't worry about like recreating these word problems inside of your math notebook or anything like that. Okay, since these are all word problems, we know that one of the most important things to do when working on word problems is to read the problem really carefully and then underline the most important parts. So let's take a look here. It says Stuart bought 3 1/4 gallons of apple juice to make punch. How many quarts of orange juice did he buy? Now we know that the number one thing we want to make sure that we underline inside of each word problem is the numbers and their units. In this word problem, there's only one number, and the units is the gallons. So it's 3 1/4 gallons. Then it says there's other math words that we definitely want to make sure that we underline as well. Like, for instance, we want to underline quarts, but actually we want to make sure that we find the question too. So the question is here: how many quarts of orange juice did he buy? So those are really the only parts of the problems that we actually need. We need to know that he bought 3 1/4 gallons, and that the question is, how many quarts of orange juice did he buy? I went ahead and double underline quarts there because we underline that word both because it's in the question and because it's a math word. Okay, so we want to start by writing down the number 3 1/4. We know we have that amount in gallons, and we know we're trying to find it in quarts because we have the amount in gallons, but the question is how many quarts of orange juice did he buy? So we have the amount of orange juice that he bought in gallons. We're trying to find the amount of orange juice that he bought in quarts. So it's a simple conversion problem, just like the ones we've been doing throughout this chapter. Now remember, when you're doing conversions, when you're going from a larger unit to a smaller unit, you multiply. And when you're going from a smaller unit to a larger unit, you divide. So we're going from gallons, which are big, to quarts, which are smaller, so we multiply. So we write 3 1/4 times. 3 1/4 times what? Remember, we always multiply or divide by the amount of the smaller unit that can fit into one of the larger unit. And since there's 4 quarts in 1 gallon, we multiply by 4. In order to multiply this mixed number times this whole number, we need to change both of these numbers into fractions. So we'll actually change them both into improper fractions. Now, remember, the way that we change a mixed number into an improper fraction is we simply multiply the whole number times the denominator, and then we add the numerator to that. So 3 times 4 is 12, plus 1 is 13. And then the denominator 4 stays the same, times. And all we have to do to the whole number 4 to make it into a fraction is just give it a denominator of 1. Now we have 13/4 times 4 over 1, and we can cross cancel here because the greatest common factor for 4 and 4 is 4. So we divide 4 by 4 and we get 1, and we divide this 4 by 4 and we get 1. Now we have 13 over 1 times 1 over 1, and that's 13 over 1. And 13 over 1 simplified would just be 13. So how many quarts of apple juice did Stuart buy? He bought 13 quarts. Now, if you're following along with me and doing this lesson with me, the part that you should have written down is all this. If you have your math notebook, make sure you're doing this work with me inside of your math notebook. But if you only have a piece of scratch paper or whatever you have, just make sure that you're doing the work with me. Okay, this next one says, Stuart bought 8 fewer pints of soda than apple juice. How many cups of soda did he buy? So again, we want to make sure that we underline all the numbers with their units and all of the math words, and we want to find the question, and we want to underline that. So we need to underline 8, and then we make sure that we underline the unit too. So it's 8 what? 8 pints. We should also underline fewer, because fewer is actually an operational vocab word. If you think about it, fewer shows you that there's going to be some kind of subtraction, because when you're subtracting, You're seeing how much less one thing is than something else. Okay? Now, here's the question. How many cups of soda did he buy? And we want to double underline cups because that's one of our math words. Okay, now look, it says Stuart bought 8 fewer pints of soda than apple juice. The problem is we don't know how many pints of apple juice he bought. We only have it in quarts, so we need to do a conversion. Excuse me. We have the amount in quarts. We know it's 13 quarts. We need to find it in pints. So we start by just whatever number we have, we write it down, 13. Now we're going from quarts to pints, so we multiply because we have the answer in quarts. We're trying to find the answer in pints. Now there's 2 pints in every quart, so we multiply 13 times 2. So that's 26 pints. Now that's not the answer to the question. This is a multiple step problem. But that's something we have to figure out before we can find the answer to this question. Because if he bought 8 fewer pints of soda than apple juice, we need to know how many pints of apple juice he bought. So now that we know that, we can figure out how many pints of soda he bought. Because he bought 8 fewer pints of soda than apple juice. So if he bought 26 pints of apple juice and he bought 8 fewer pints of soda, that's the subtraction problem, 26 minus 8. Okay, now 26 minus 8, you could either borrow or you could just do it in your head. It would be 18 because we can borrow from the 2, make it a 1, making this 6, a 16. 16 minus 8 is 8, and 1 minus nothing is 1. So that's 18 pints of soda that he bought. But notice something important in the question. The question doesn't ask us how many pints of soda he bought. It asks us how many cups of soda he bought. So now we have to do another conversion. We have 18 pints, and we need to find out how many cups that is. So we start, whatever number you have, you just write it down. Then you decide if you're going to multiply or divide. Remember, if you're going from a larger unit to a smaller unit, you multiply. If you're going from a smaller unit to a larger unit, you divide. So we have the answer in pints. We're trying to find the answer in cups. Pints are bigger than cups, so we're going from a larger unit to a smaller unit, so we multiply. What do we multiply by? We always multiply by the amount of the smaller unit that can fit into one of the larger unit. Since there's 2 cups in 1 pint, we multiply by 2. So what's 18 times 2? We can set that up as a problem on the side. 2 times, now make sure you're doing, make sure you're doing all of this with me. Everything I write down, you should write down too. You should do every single step with me. 2 times 8 is 16. We carry the 1. 2 times 1 is 2, plus 1 is 3. So how many cups of soda did he buy? He bought 36 cups. That's the answer. Okay? And by the way, maybe I didn't explain this explicitly enough, but you had to use this problem in order to find this one. This word problem referenced back to this first one. Okay, let's move on to the next one. This one doesn't reference back to anything. It's a standalone word problem. Dustin walked for 1/2 mile on Tuesday, 3/4 mile on Thursday, and 1/4 mile on Saturday. What is the total distance he walked? Okay, step 1 is underline all of the numbers with their units. 1/2 mile, 3/4 mile, 1/4 mile, and then find the question, what is the total distance he walked? Okay, so we have 3 different fractions in a list here, separated by commas, and then it says what is the total. You want to double underline the word total. So if you walked a certain amount each day for 3 days and you wanted to find what the total was, what operation would you want to use? You're just combining them. So the most obvious operation that we would want to use would be addition. So we need to add 1/2 plus 3/4 plus 1/4. And you know what? I'm going to rewrite that over here because there's no spot to write the answer. 1/2 plus 3/4 plus 1/4. And notice that I stacked these up in order to add them because we're going to have to make common denominators. So 1/2 has a different denominator than 3/4 and 1/4, so we need to make the denominators the same. And the way we do that is we find the least common multiple for 2, 4, and 4. Now, a lot of you can just look at 2, 4, and 4 and pretty much know what it is. You know 4 is a multiple of 2, so that means 4 has to be the least common multiple. So we're going to change 1/2 to be a fraction with a denominator of 4. So we multiply from our old denominator to our new one. 2 times 2 equals 4. And then whatever you do to the bottom, you do to the top. 1 times 2 equals 2. So now we have 2/4 plus 3/4 plus 1/4. And remember, when we're adding fractions, we just add the numerators and the denominator stays the same. That's why they need to be like fractions. 2 plus 3 is 5, plus 1 is 6. And then the denominator 4 stays the same. Now obviously that's a fathead, so we can't leave it the way it is. We have to divide the denominator 4 into the numerator 6. How many times can 4 fit into 6? 1 time. 1 times 4 is 4. 6 minus 4 is 2. So it's 1 and 2/4. Now we still have some more simplifying to do because the fraction 2/4 can be simplified. And anytime you have a fraction where the numerator is exactly 1/2 of the denominator, you know it simplifies to 1/2. So this really shouldn't be written as 1 and 2/4. It should be written as 1 and 1/2. So that's how much he walked. He walked 1 1/2 mile. Okay? That's the answer to the question. All right, the next one. It says Jeff sorted the leaves in his leaf collection. Who would have a leaf collection? They measure, let's underline the important parts, 1/4 inch, 3/4 inch, 1/8 inch, and 1 1/8 inch. What is the difference between the longest leaf and the shortest leaf? And we need to underline the question. What is the difference between the longest leaf and the shortest leaf? And we double underline difference because it's a math word. Now the word difference is a math word because it's an operational clue word. What operation does the word difference give us a clue that we're going to do in this problem? Well, the difference is the answer to a subtraction problem, so we know we need to subtract. What are we subtracting? We're subtracting the shortest leaf from the longest leaf. So which of these leaves is the shortest and which is the longest? Well, we have 1/4, 3/4. 3/4 is bigger than 1/4, and then we have 1/8. 1/8 is smaller than both of those. And 1 1/8 is obviously bigger than all of them so far because it has a whole number and a fraction. So this one has to be the biggest one, and this one has to be the smallest one. So we're going to subtract 1 1/8 minus 1/8. And this is actually pretty easy because 1/8 minus 1/8 would be 0/8, which we don't even need to show that because 0/8 just means 0. And 1 minus nothing is 1. So the answer is 1. We wouldn't write 1 and 0/8 because what's the point in that? We're just saying we have 1 and then we have, on top of that, we have nothing, 0/8. So there's no point in showing the 0/8. The answer is just 1, and it's actually 1 inch. That's the difference between the longest leaf and the shortest leaf, 1 inch. Okay. The last two problems on the back. The first one says, what is the fair share of the leaves? Remember, to find the fair share, we add up all the fractions, or they might not be fractions, they might be mixed numbers, or they might be whole numbers. You add them all up, and then you divide by the total number of fractions. So you add up all the numbers and then you divide by the total number of numbers, basically. So what are our fractions again? We have 1/4, 3/4, 1/8, and 1 1/8. So let's rewrite all those. 1/8, 3/4, 1/4, and 1 1/8. The first step is to add all of those up, and then we'll divide them by 1, 2, 3, 4 because there's 4 total numbers. So we add up 1 1/8, 2 1/8, 2 1/4, to 3/4. Now, we can't add these up together the way they are now because they aren't all like fractions. So we have to find the least common multiple of 8 and 4, and that's pretty easy. We know 8 is a multiple of 4, so we're going to make our new denominator 8 for both of the fractions that currently have 4 as their denominator. We multiply from the old denominator to the new denominator, and then whatever we do to the bottom, we do to the top. 4 times 2 is 8. 3 times 2 is 6. 4 times 2 is 8. 1 times 2 is 2. So we've changed 1/4 into the equivalent fraction 2/8, and we've changed 3/4 into the equivalent fraction of 6/8. Now we can add all these fractions together. 6 plus 2 is 8, plus 1 is 9, plus 1 is 10. So we have 10/8, and then 1 plus nothing is 1. So we have 1 and 10/8, but of course that's an improper fraction, so we need to fix the fathead, and we can do that by dividing the denominator 8 into the numerator 10. 8 can fit into 10 one time. 1 times 8 is 8. 8 minus 10 minus 8 is 2, so it's 1 and 2/8. And we already know from right here that the simplified version of 2/8 is 1/4, so it should actually be written as 1 and 1/4. So we're going to write that over here, 1 and 1/4. That's all the fractions added together. It equals 1 and 1/4. Now, no, I'm sorry. I am wrong. And I realized I was wrong just now because I was like, how could 1 and 1/8 plus 1/4 plus 3/4 plus 1/8 only be 1 and 1/4? I forgot something, and it's that when you simplify the fathead, you then need to add that back into the whole number. So the answer isn't 1 and 1/4, it's 2 and 1/4. Because the 1 and 1/4 is just the 10/8 changed into a mixed number. We need to give that mixed number back to the whole number 1. So the answer is 2 and 1/4. And what do we do with that 2 and 1/4? We divide it by the total number of fractions, 1, 2, 3, 4. So let's change 2 and 1/4 into an improper fraction now. 2 times 4 is 8, plus 1 is 9. So that's 9/4. Now, remember, in order to divide it by 4, we first give 4 a denominator of 1. But the way that we do this division problem is we change the division to multiplication, and then we flip-flop the second fraction. So we change 4 over 1 to 1 over 4. And now we can just multiply straight across. 9 times 1 is 9. 4 times 4 is 16. And so the fair share of all these fractions is 9/16. All right. The next one, Everett and his 2 brothers each use 2 1/4 cups of milk for breakfast each day. How many fluid ounces do they use in 5 days? Okay, this is a multi-step problem. We start by underlining all the numbers, 2 1/4 cups and 5 days. And we want to make sure there's another number. It's Everett and his 2 brothers. That's the number 3. It's easy to miss stuff like that, but that's a number. Everett and his 2 brothers, that's the number 3. And then we want to make sure that we underline the question, how many fluid ounces do they use in 5 days? We want to double underline 5 days and double underline fluid ounces, because those are math words. All right, this is a multi-step problem. We need to find out how many fluid ounces they use in 5 days, but we only have how much each of them uses in cups per day. So let's start by finding out how much all 3 of them use in cups per day. Okay, so if they each use 2 1/4 cups, and if there's 3 of them, that means we need to multiply 2 1/4 times 3 to find out how many cups of milk they each use per day. So let's change 2 1/4 into an improper fraction. 2 times 4 is 8, plus 1 is 9. The denominator 4 stays the same, and we change 3 into a fraction by giving it a denominator of 1. Okay, now 9 times 3 is 27, and 4 times 1 is 4. That's a fathead, so we fix the fathead by dividing the denominator 4 into the numerator 27. What times 4 gets closest to 27 without going over? Well, think about it. 4 times 7 is 28, so that's too big. 4 times 6 is 24, so it's 6 times. 6 times 4 is 24. and 27 minus 24 is 3. So they use 6 3/4 cups of milk all together per day. Now we want to know how much they use in 5 days. So we now need to take how much they all three together use in 1 day and now multiply that times 5. And that'll tell us how many cups of milk they use in 5 days. So again, let's change this into a improper fraction, but we already have it as an improper fraction. It's 27/4 times 5 over 1. So we can't cross cancel, so we do 27 times 5 and 4 times 1. So let's do 27 times 5 on the side. 5 times 7 is 35. 5 times 2 is 10, plus 3 is 13. So 27 times 5 is 135. And then 4 times 1 is 4. And that's obviously a fathead, so we need to fix the fathead. Let's do it over here by dividing the denominator 4 into the numerator 135. 4 cannot fit into 1, but it can fit into 13. So we put the first part of our quotient above the 3. How many times can 4 fit into 13? Well, 4 times 3 is 12. That's as close to 13 as we can get without going over. So 4 can fit into 13 3 times. 3 times 4 is 12. Now we subtract. 13 minus 12 is 1. 1 is smaller than 4. So now we bring down the 5. And 4 can fit into 15. How many times? Well, 4 times 4 is 16. That's too big. 4 times 3 is 12. So it can only fit in 3 times. 3 times 4 is 12. And 15 minus 12 is 3. So it's 33 3/4. Now, is the answer 33 3/4? You might think so if you're not careful, but the question doesn't ask for how many cups they use in 5 days. It's a little tricky. It asks for how many fluid ounces they use in 5 days. So we have to do another conversion. We know they use 33 3/4 cups, and we want to know how many fluid ounces that is. Start by writing the number 33 3/4. Are we going to multiply or divide? Well, we're going from cups, which are bigger, to fluid ounces, which are smaller, so we multiply. And what do we multiply by? Well, since there's 8 fluid ounces in each cup, we multiply by 8. Okay? Now, we need to change 33 3/4 into an improper fraction, so we multiply 33 times 4 and add 3 to it. Let's do that on the side. 33 times 4. This is a lot, isn't it? Make sure you're paying attention because you're going to have to do a problem exactly like this on today's quiz. 4 times 3 is 12. We carry the 1. 4 times 3 is 12 plus 1 is 13. So 33 times 4 is 132. But then we need to add this 3 to it, so that's 135. 135, the denominator 4 stays the same, times, we change 8 into a fraction by just making it 8 over 1. Now we can cross cancel here, which makes it a lot easier because 4 and 8 have a common factor. The greatest common factor for 4 and 8 is 4, so we divide 4 and 8 by 4. 4 divided by 4 is 1, 8 divided by 4 is 2. So now we just have 135 times 2. And so let's do that on the side. 135 times 2. 2 times 5 is 10. We carry the 1. 2 times 3 is 6, plus 1 is 7. 2 times 1 is 2. So it's 270 over 1 times 1 is 1. And that simplifies to 270 fluid ounces. Okay, I just showed you how to do 6 word problems. Now, on today's quiz, there's 6 of basically the exact same word problems. Let me show it to you. Today's lesson is, the date is wrong on it right now because I haven't changed it yet, but it's called Solve Measurement Problems. Here's what today's quiz looks like. It has 6 questions, just like we just did 6, and they're the exact questions, just with different numbers and different names. So if you were really paying attention as I did each of those 6 problems, hopefully you now know how to do these. Now these are hard, guys. These are tough problems, multi-step, just like the ones I just did with you. So if you get to the 3rd problem and you don't know how to do it, simply re-watch how I did the third problem in this video, the one about Dunstan. If you get to the second problem and you don't know how to do it, simply re-watch how I did the second problem in this video, the one about how Stuart bought 8 fewer pints of soda than apple juice, and so on and so forth. If you get to the last problem, the sixth problem, and you kind of get confused, re-watch how I did the sixth problem, the one about Everett and his 2 brothers, in this video, and then see if you can apply it to this particular problem. Now, don't expect this to be easy, and make sure you do your very, very best. I don't expect you to necessarily get 100%. I just expect you to try your very, very best. And this is one of the harder independent work lessons of the year, but that's actually good because it's really good practice for the end of the year test, where the questions are really hard and some of them are multiple step problems. Okay? Go ahead and do your very best on this quiz, and I will catch you next time. This is Mr. Dauber signing off.